Hello everyone, welcome to Agent Stacks. So have you ever wondered why ChatGPT sometimes give you completely wrong answers with so much confidence? So this problem is something which LLM can't figure out and or maybe LLM doesn't know. And that's what exactly why one of the most important concepts in AI engineering exists, which is RAG, which is Retrieval Augmented Generation. If you have looked at AI engineering job description recently, you will notice one thing. Almost every company is looking for engineers who understand RAG, whether it's chatbot, enterprise search, document assistant, legal AI, healthcare, finance, or customer support. RAG is everywhere. So in today's video, we are going to understand RAG from absolute scratch. We'll first understand why LLMs failed and what's fine-tuning, in-context learning, RAG was introduced, and indexing. So lot of things we are going to understand in this video. This video will be more of a theory because when you are starting RAG, understanding theoretically is very important. And by the end of the video, you will understand entirely about RAG conceptually, and then we can start actually implementing one use cases in RAG. So now let's get started. So before we begin, if you are new here, make sure to check out the AI engineering playlist on the channel where we are learning AI engineering step by step from LangChain to agents, enterprise level projects. So I have something special for you. I have prepared one detailed AI engineering interview notes based on everything I have learned while building projects and preparing for interviews. I have put everything based on my 3 years of experience, whatever I have in this field. And if our channel reaches 100 subscribers, I will release those notes completely for free for everyone. So if you don't want to miss on that, please subscribe to Agent Stacks. And now let's understand why RAG even exists. So firstly, we need to understand what is that LLM can't solve. So we all don't know that LLMs are powerful. They have several limitations and there may be lot of things which maybe LLM can't solve. So here some things like knowledge cutoff, no access to private data, hallucinations, no real time knowledge, static knowledge. So there are a lot of things which LLM can't solve. So for understanding these all things, we need to understand that despite all this intelligence, they have several important limitations. First, they don't know your private company data. So imagine you're asking here, like, what is our company's leave policy? And LLM will respond unable to answer accurately because it has never seen your internal HR documents. So this is something which you may be feeling like that is something which here something would have solved. And that is where exactly RAG comes to picture. So if a company has updated its policy or pricing yesterday, or a new government policy has announced this morning, the model won't automatically know it. Third, they cannot rely completely on the answers which there is no documentation available then. So, for example, if you upload a 500 page of company handbook and ask what is the reimbursement policy for the international travel, the model has no memory of that document unless you provide some relevant information. And finally, LLM can hallucinate as well. That means they will sometimes generate answers that sound convincing but are completely wrong. These limitations create a huge challenge for enterprise AI applications. So now how do we solve them? So first let's look on one traditional solution which is called as fine tuning. So now what is LLM fine tuning? So fine tuning means taking an already trained language model and training it again on your own dataset. So think it of like teaching an experienced employee on a new specialization. The employee already knows English, communication and problem solving, but now you're training them specifically on to become a insurance expert. So similarly, instead of training an LLM from scratch, we continue training it using some domain specific data. For example, a hospital could fine tune a model on medical resorts. Then we have a law firm which could fine tune a model on legal documents. A bank statement which could fine tune a bank which can fine tune a model on financial terminologies. And after fine tuning, the model becomes much more better at understanding what specific domain was. And however, fine tuning also has some limitations, which we can discuss later. So before moving on to the next part, we'll understand what are the steps of fine tuning. So let's understand how fine tuning works. So it first collects data, and then it will clean and pre-process the entire data set. It will remove duplicates, incorrect labels, and irrelevant information. Thirdly, it format the data set according to the model's training requirements. And then it will choose a pre-trained model like Llama or Mistral. Fifth, it will train on model using its own data set. And finally, it evaluate the model and deploy it. So although the process sounds straightforward, but it requires a large amount of high quality data, significant computational resources, time, and expertise. That's why fine tuning isn't always the best solution. So now comes what is in context learning. So now suppose you don't want to retain the model. Instead, you provide a relevant information directly inside the prompt. So this is called as in context learning. So for example, you tell the model, our company has 24 annual paid leaves. So based on this information, answer the employee's question. So now when the user asks, how many paid leaves does my company provide? So the model answers correctly because you have included that requirement in the pod and the prompt was retained. So it simply used the context that you gave it. That is why it is called as in context learning. But imagine doing this manually for hundreds of PDF or thousands of documents. Clearly, that's not a practical approach, and that's what exactly where RAG comes in. So we have some types of prompting which we have discussed already in our previous videos, which are zero shot prompting, one shot prompting, few shot prompting. And in the examples also which we have taken for the project, we have already mentioned that these are the some conditions which I am giving to the context itself for the LLM, that while you give the answer, just keep in mind these all situations and these all conditions. And now comes the most important part of the entire video, which is what is retrieval augmented generation. So instead of retraining the model or manually copying information into the prompt, RAG automatically retrieves the most relevant information from your knowledge base and you before generating the answer. So basically, think of it like an open book exam. So instead of answering from memory, the student first opens the textbook, find the relevant chapter, reads it, and then answer the question. And that's what exactly RAG works. The model first searches for the relevant information, then uses the information to generate an accurate answer, and this makes response more reliable and more up to date and grounded for the actual data. So, when I am creating any RAG application, there are certain components which we need to understand. So, first is the retriever, then comes the vector database, then comes the embedding model, and then comes the LLM. So, the key idea of this entire architecture is retrieve first and then generate later. So here are some of the best use cases that you can build using RAG. So RAG is used almost everywhere in enterprise AI, support chatbot that answer questions from company documentation, healthcare assistants that retrieve information from medical guidelines, legal assistants that search contracts and legal documents, HR chatbots that answer employee policy questions, banking assistant that retrieve financial revelations, research assistant that search on research papers before generating the reports, then educational tutors that answers questions based from the textbook, enterprise knowledge. So there are a lot of use cases that maybe you can take a screenshot of this slide of the screen and you can understand like what all things I can build from my understanding based on the use cases which are provided here. So whenever an AI needs to answer questions from a large collection of documents, RAG is usually referred as the solution. So now comes what is index. So before RAG can search documents efficiently, those documents need to be prepared. And this preparation process is called as indexing. So suppose you have a 500 page of video and we don't store it in one giant block. So instead, the document is divided into smaller chunks. Each chunk is converted into embeddings, and those embeddings are stored in a vector database. And now the information becomes searchable. So think of a book. Instead of reading every page to find one topic, you first check the index. The index tells you exactly where to look, and that's exactly where what indexing does for AI systems. So it makes searching thousands of documents extremely fast. So this is what indexing is all about. So whenever you are dealing with RAG kind of application, indexing is very important because it is the process to convert documents into searchable vectors. And now let's understand the RAG workflow. So once before we understand, there is a scenario, there is an entire system which is working for the completion where the document is loaded to the response is generated. So first the user asks the question. So for example, someone like me asks a question. So the question is converted into embeddings, and then the embeddings, the vector database is the one where the embeddings are stored, and with the help of vector db, it searches the most relevant document chunks. Those retrieved chunks are added to the prompt, and it completes the prompt which is sent to the LLM, and LLM generates an answer using both the user's question and the retrieved information. And notice something important here: the LLM never searches document directly. It only receives the most relevant context, and that's what makes the RAG different. So, highlighting on a very high level that it's something like I give a question, and that question's answer is somewhere around 500 page of documents. So, it doesn't check the entire document. It first you will get the vector database have the knowledge of entire data, entire book, which is a 500 page. So it will give a chunk of information in the form of vector, and that chunk of vector and the given information is then taken to LLM, and then based on that information LLM is giving the output. So this is how powerful RAG is. Now let's understand the difference between fine tuning and RAG. So students often confuse these two concepts because, so let's make it simple. So fine tuning changes the model itself, but RAG doesn't. Fine tuning retrains the model, RAG uses external knowledge. Fine tuning is expensive because, as I mentioned, lot of computational cost, lot of data. So it's not that efficient. But RAG is very cost effective. Then comes, as I mentioned, requires GPU. It doesn't need any training method. Then it's difficult to update. Yeah, it's for sure because you have to retrain the entire model. But updating RAG is very easy because you just have to update a document and push it into the database. Then knowledge stored in model wakes, but here knowledge is stored in the WebDD. Long training time, it's fast implementation. Best for changing model behavior, best for adding new knowledge. So this is what on a very high level is the difference between fine tuning and RAG. So now let's understand what are the problems that actually are solved using RAG. So it reduces hallucinations by grounding answer in real document. It allows AI to never answer questions about private data. It works on the data which it doesn't have any private information. It cannot answer organization specific question. It is never real time information. So for example, I gave like in the morning if something new has came into picture, you will never get the information for that. So this is where the RAG will fail. But after RAG, uses of enterprise knowledge is very easy now. You just have the information you have to push into database and then you can retrieve it using RAG. Then retrieving latest documents is very easy. It gives more accurate answers. It has reduced hallucinations because definitely that the with the information which we need actually that is being shared here, and also answers are based on retrieved evidence. Also, it is easily scalable with new documents. So tomorrow, new information will come. You don't have to do hundreds of different work. You just have to maybe run one two script, and then your entire thing is updated. So this is what was RAG all about. So congratulations if you have watched this video till the end. You have understood one of the most important concepts in modern AI engineering. Almost every enterprise today use RAG, whether it's an application or it's an healthcare application, finance, legal, HR, customer support uses RAG in some other form. So the best part is this is not just beginning. In the upcoming videos, we'll be talking about more theory and we'll be building about a RAG application from scratch using LangChain, vector databases, embeddings, retrieval pipelines. So you will see exactly how all these concepts come together in a real project. And don't forget my promise, once we reach 100 subscribers, I will release my AI engineering notes completely for free. And these are the notes I prepared while learning AI engineering and building projects. And I think they will save a lot of time for you. So if you found this video valuable, please like and subscribe Agent Stacks and share this video with someone who is learning AI engineering. Thank you so much for watching. Keep learning, keep building, and I will see you in next video.